Alright folks, today we're working on 6.4 A and B. We're trying to determine if a function is invertible, and we're also trying to find the inverse of a function. So before we move on, we should talk about what an inverse function actually is. So the definition of an inverse function is just a function that reverses or undoes, so you like that word better, that reverses another function. And we have some notation. So, function. If I said we have, so for example, we have f of x. So this is a function that does a thing. Right now we have g of x. Then the inverse function, so f of x has an inverse function given by the notation f inverse of x. And this is pronounced f inverse for this little symbol right here because it's the inverse word of x. So let's look at an example with some actual numbers. So I've got an example of f of x is x plus 1 and g of x is x minus 1. So if we put a number in for f, I don't know, let's 5, sure. So let's find f of 5 is going to be 5 plus 1, which is going to give us 6. That says if we put 6 in, it should give us 5 if these are inverse functions. So then g of 6 is going to be 6 minus 1, which gives us 5. Woohoo! So f of 5 gave us 6, and then g of 6 gave us 5. So the domain of the input is the range of the output, and the range of the input is the... I've done this weird. Okay, so the domain and range are going to be switched. So I'm just going to circle the 6's and box the 5's. So it looks like the domain and the range are flipped, and the domain and the range are flipped. So the domain and the range of the original function are the range and domain of the inverse function. So we can say, therefore, f of x and g of x are inverse, is the way we can say this. So they can say inverse function, but f of x and g of x are inverse. Okay, so let's find some out functions. So find the inverse of a function. So this is figuring out what they kind of looks like. Let's find the inverse of a function. So example 1, find the inverse of a function of f of x is equal to 2x plus 3. So we've got a couple steps. The first thing we need to do is, instead of writing it with this f of x symbol, let's write it with y equals. I'm going to work over here on the left. So we know that we can kind of associate f of x and y. So the only thing I'm going to change is just, instead of writing f of x, I wrote y. Okay, so that's the first step. So 1, we're going to replace with y. Replace f of x with y. Step 2 is you're going to switch x and y. We're going to switch x and y spots. So wherever there's an x, you write y. Wherever there's a y, you write x. And in step 3, and this is the hard part, we need to solve for y. So I'm just going to do some work over here. So I've got x equals 2y plus 3. So if I need to get y by itself, I'm going to subtract 3 on both sides. They're not like terms, so it's just x minus 3 equals 2y. And then I'm going to divide by 2. Because I can't actually divide by 2, I'm just going to leave it as x plus 3 equals, or x minus 3 over 2 equals y. So y equals x minus 3 over 2. So if you were to say, hey, what's the inverse function? Well, I could write f inverse of x is equal to x minus 3 over 2. So our last step is really just to rewrite this y as f inverse of x, because this is the inverse function of your original one. And if you were to put a number in, so let's just pick 2. 2 times 2 is 4, plus 3 is 7. And if we put in 7 down here, 7 minus 3 is 4, divided by 2 is 2. So our inputs are output, and our outputs are input. Woohoo! They're inverse. Okay. Find the inverse function of g of x is equal to x squared plus 2. So let's do these same steps. Let's replace f of x with y, or in this case g of x with y. So we get y equals x squared plus 2. Let's switch x and y. So wherever there's an y, we're going to write x. Wherever there's an x, we're going to write y. And now we need to solve for y. So it looks like I'm going to get y by itself. Let's move this 2 first. So I get x minus 2 equals y squared. So then undo a squared, we're going to take the square root, which says I have the square root of x minus 2 equals y. Can't take the square root of this. The square root and the square root are going to cancel. So that says g inverse of x, the inverse function of g, is the square root of x minus 2. So that is the inverse. And we could just check by plugging a number in. Let's just check, I don't know, 0. 0 squared is 0, plus 2 is 2. 2 minus 2 is 0. Square root of 0 is 0. So it works. Okay. One more example of finding the inverse function. So find the inverse function of h of x, which is equal to the square root of 2x minus 5. Again, replace f of x with y, or in this case h of x. So y equals the square root of 2x minus 5. Switch x and y. Wherever there's an x, write a y, and wherever there's a y, we write an x. And now we have to solve, and this is always the hard part. So I don't like this square root, so let's get rid of it. Just like in the last one, we square rooted to get rid of a square. Let's square both sides. What you do to one side, you gotta do the other. Let's square both sides to get rid of the square root. So we're left with x squared is just x squared. Squared and squared are going to cancel. 2y minus 5 is left over. So if I want to solve for y, I'm going to need to add 5 on both sides first. Remember, we're working like a reverse PEMDAS, if you want to think about it like that, reverse order of operations, equals 2y. Now we need to divide by 2. So we get y equals x squared plus 5 all over 2. So it says the inverse of h inverse of x, is equal to x squared plus 5 all over 2. I will leave you to plug in a number for your input for h, and then take your output and plug it in for your input for h inverse, and then see if you get the right one. Okay, we got a practice sheet. We'll get going.